Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you should have x plus 4 times x minus 1. For the math knowledge question, you're going to want to set up a system of 2 equations, probably going to be quicker. If you want to just do guess and check, you can. We brought 3 large decals and 2 small decals for $1.30. All he remembered about the price was that the large decal was 10 cents more than the small decal. And then that's your system of equations. And so you can plug s plus 0.1 into here. Alright, so you distribute your 3. And then you combine your like terms and subtract the 0.3. And so S is going to be 1 divided by 5 is going to be 20 cents. And it says how much did one small decal cost. So 20 cents would be your answer. Alright, so we're looking at lesson 16. We're looking at logs of products and quotients, logs of powers, and then exponential equations. All of this should be reviewed from either Algebra 2 or pre-calculus. You should have covered all log rules and exponential equations, but we're going to go back over them in this lesson. So these are your rules for your logs when you have products and quotients. If you have log base b of m times n, you can separate it into 2 logs with a plus sign, where you have log base b of m plus log base b of n. If you are dividing, you separate it with a minus sign. And then it says if you have log base b of x equals log base b of y, basically the 2 log base b's cancel out, so x equals y. So those are some of your rules. We're going to cover one more in just a minute. So we want to solve this for x. So the first thing you want to try and do when you have a log equation is to either get one log on each side of the equation, only a log on each side of the equation, or one log on one side of the equation and a number on the other. And so we have a number on the right side, so we want to figure out how to get this log and this log combined together. They both have a base of 4, and there's a plus sign in between them. So how can we combine the x plus 2 and the 5? You can multiply them together, so it's going to be 5 times x plus 2. And then it's going to equal 2. So now that we've combined these into one log, we can use our exponential conversion from log to exponential form, and we can make this is the same thing as 5x plus 10. So we can take 5x plus 10 and bring it down, and then the 4 can push this 2 up, put it into exponential form. So we have 5x plus 10 equals 4 squared is going to be 16. And then subtract your 10 to make 6, and then divide by 5, so x equals 6 over 5. We have to always check to make sure that our arguments, which is here and here, are positive. This one is 5, which is positive. If we plug in 6 over 5 plus 2, that's still going to be a positive number, so 6 over 5 does work for our answer. Looking at the next one. This one is natural logs. However, the same rules apply for logs and natural logs, because it's just a log base e. So the way that we combine these two on the left side, there's a minus sign, so we're going to divide. So we're going to have natural log of x minus 1 over x plus 2. And then on the right side we have the natural log of 14. We don't need to try and put it in exponential form because they both are the natural log, so the natural logs can cancel, so that we have x minus 1 over x plus 2 equals 14. From here, we're going to cross multiply. So x minus 1 equals 14x plus 28. And then you're just going to solve for your x. So 13x is going to equal negative 29. And so x equals negative 29 over 13. However, what do we have to do to check to make sure that this number works? We need to plug it into our arguments. So our arguments are here, here, and here. This one's positive. So we don't have to worry about checking it. If you plug negative 29 over 13 in here, and then you subtract 1, that is still going to be a negative number. So this does not work. So the answer is no solution. Since this was a negative number when we plugged in the x value that we got. Alright, so this is the other rule for your log. It's the power rule. Basically, if you have a number for your exponent, you can move it to the front, or if it's a variable. Or if you have a number that is in front, you can move it to the exponent. So if you want to write that down, that's the power rule for logs. So let's look here. We always want to try and use the power rule first. So we check to see, and we do have a number in front of our log on this first one. So we're going to move that 2 over to the exponent here. So log base 8 of x to the 2, and then plus log base 8 of 4 equals 1. So from there, we want to combine these two logs into one, and there's a plus sign. So we get to multiply them. So log base 8 of 4 times x squared equals 1. From here, you're going to put it into exponential form. So 4x squared equals 8 to the first power, which is just 8. So we can divide by 4. So x squared, 8 divided by 4 gives you 2. And then take the square root of both sides, and your x would technically be plus or minus the square root of 2. And I say technically because when we go back here to plug in, can we plug in a negative square root of 2? No, because we can't have arguments that are negative. So x is only going to equal the positive square root of 2. But algebraically, you do get plus or minus square root of 2. Alright, looking at another example. So on this one, if you look in the book, this isn't how they solve it exactly, but this is just a personal preference. Do you notice how all of them are negative? I'm going to change all of the signs to positive. I'm going to multiply everything by -1. And I think it makes it a lot easier of a problem to work with. And you can do that if, that one had been negative and that one, but not that one. You could switch all the signs. I just find it makes it easier to work with when they're all positive, or when most of them are positive. But that's just a personal thing. You don't have to do that. It'll work out the same way. So if you want to look at the book on page 99 and see what they do, you're more than welcome to do it their method. Or you can move these two terms over to the right side and that one over, or you could just switch these two. There are a lot of different ways you can work it. You'll get the same answer either way. So the first thing we need to do is move this 2 to the exponent. So that's going to become 3 squared, which is 9, and then plus the natural log of x minus 1 equals the natural log of 1/4. So we can combine these two on the left by multiplying them because there's a plus sign. And then we can cancel the natural logs because there's 1 on each side. You can't cancel them here because you have to have only 1 on each side of your equation. So this is going to be 9x minus 1 equals 1/4. So then if you add 9, you're going to have 9x equals 9 plus 1/4. This is going to be 36 over 4. So 37 over 4. And then you can divide by 9 or multiply by 1/9. And so x would give you 37 over 36. And so again, we have to check and make sure our arguments are positive. This is the only variable we have to check. So x minus 1. Is 37 over 6 minus 1 still positive? It is. It's going to be 1 over 36. And so that would be your answer. Moving on to the exponential equations. So we want to solve this without using logarithms. We'll do one where we have to use logs in a minute. But these, if you can avoid the logs, it does make it a little bit simpler and quicker and less writing. So that makes it go by quicker just because you don't have to write as much. The way you know if you can do without logarithms, 8 and 16, can those both be written as some number to a power, the same number to a power? So can we write this as like 3 squared or 4 squared, and this one as 3 to the 4th or 4 to the 3rd or something? We can both, 8 can be written as 2 cubed. So instead of 8, I can make it 2 cubed. And then for 16, I can make it 2 to the 4th. I could also write 4 squared, but then this is a base of 2 and this one's a base of 4, and that's not what we want. We want this number here and this number here to be the exact same number with a different exponent. So you wouldn't want to use 4 squared for 16. Even though that is 16, this is the method that you're going to want to use. So now that we have them in the same base, these, when you have a power raised to a power, you're going to multiply. So this is going to be 2 to the 9x plus 6, and then 2 to the 4th. From here, since our bases are the same, since they are both a 2, we can cancel them, and our exponents are going to have to be equal to each other. And so then you just solve for your x. And so x would be negative 2/9. And you don't have to check this one to make sure that it makes it positive or anything, because that doesn't matter. You can check this on the calculator, and I'll show you how real quick. So you can do 8 and then 2 and we're doing 3, and our x is negative 2/9, and then plus 2, and that should equal 16, and it does. So that's how you can check and make sure your answer works. Just plug it into the equation. Okay, now looking at this one. So on this one, there's no way to make 10 and 8 have the same base. So we're going to have to use logs. And so the way that you do this is to do log on both sides of your equation. From there, we have an exponent, and so we can take this whole thing and move it to the front. And so you want to put parentheses around it because it's all in front of the log base 10. Now, log base 10, there is an understood 10 on these logs. We're not writing it. If you want to, you can, but you don't have to. But log base 10 of 10 is just a 1. And so 1 times negative 2x plus 2, so that's just negative 2x plus 2. So that log 10 actually just goes away because it's just an understood 1 there. So we really have negative 2x plus 2 equals log of 8. So now we just need to solve for our x. So negative 2x equals log of 8 minus 2, and then divide by negative 2. And you can leave your answer just like that. If you want to get a decimal, you can, but then you run into the risk of accidentally plugging it into your calculator wrong. So you can leave it exactly like that and move on. Sometimes the book does change it a little bit, so you have to be careful. Like the book actually makes it this. Because they put the negative in front. But if they did this, that would also be correct. So just be mindful that sometimes your answer is correct, they just write it a different way. So for this one, we want to get rid of the E if we can. So instead of using log, we're going to actually use natural log. So if you use E, if you see E, you want to use the natural log instead of just log. So again, you put the natural log in front of both, and then we take this negative 2x plus 3 and move it to the front. So negative 2x plus 3 times the natural log of E equals the natural log of 5. And the natural log of E is just a 1. If you want to check on your calculator, you can, but that's a 1, so it just goes away. So we really have negative 2x plus 3 equals the natural log of 5. So negative 2x equals the natural log of 5 minus 3, and then divide by negative 2. And so there's your answer, or one format of your answer. Again, the book is probably going to do that. Just move the negative in front, but either one of them is fine with me. Okay, we're going to look at one more example. This one is going to be a little bit more worky because we have a 5 and a 6. So if we use log or natural log, neither the 5 nor the 6 will cancel out. So you can do either one. I prefer doing log. I don't know why, because it's longer than natural log, but whichever one you want to do. You'll get the same answer. You just have to be consistent. So either only use log on this one or only use natural log. You can't switch back and forth. Okay, so that's the first thing you're going to do. And then you're going to take this 2x minus 1 and move it to the front, and this x minus 2 and move it to the front. So 2x minus 1 all times log of 5, and then x minus 2 all times log of 6. And hopefully you remember doing this last year in pre-calculus. So these, again, don't cancel out. So we have to distribute. So I like to put my x in front, and then we have 2 log 5 minus log 5, and then again x times log of 6 minus 2 log of 6. And then from there, we need to put our two x terms on the same side. So here's one x term, and here's the other. So I'm going to keep this 2 log 5 on this side, and then minus x times log of 6. So then we need to move this one over to the right side. So it's going to become a positive log base 5 minus 2 log of 6. From here, both of these terms on the left side have an x, so you can factor it out. And then from there, you're just going to solve for x. So you're going to divide by 2 log 5 minus log 6 on both sides. And so this would be your answer. Now, sometimes the book rewrites this in a slightly different way, and so I'm going to write it and then explain where it comes from. They don't on this one, but later in the year they do, and I don't know why they don't explain it or just do it always, but they kind of go back and forth sometimes. Okay, so that's also acceptable. Basically, you take this 2 right here and move it to the exponent to make that 6 squared, and that's where that 36 comes from. And then they take this 2 and move it to the exponent of the 5, and so 5 squared, that's 25. So either one of those would be fine with me. Just know that sometimes they're going to do that to their answers. So again, if you want to get a decimal number on these, you can. The book is actually going to leave them in terms of log, so you'd have to plug in what they have as their answer to get your answer to make sure that it's right. Alright, so your homework is 1 through 25, so you need to make sure to do that tonight so that we can go over any questions you have tomorrow.